All right, so 6.6 is sort of like our summary section. Now, it's going to introduce us to 2 or 3 more figures that are quadrilaterals. But again, they're not very important to us going forward, but I do want to mention them. And then we're going to talk about this hierarchy of quadrilaterals, which I think is so important, okay? So the first new figure is a trapezoid. I think you've seen it before. So a trapezoid has exactly 1 pair of parallel sides. So that's very important. So a trapezoid only has 1 pair of parallel sides, okay? We typically call those parallel sides the bases. Now, most of the time, it's the top and bottom side, but it could be turned, and they could be the left and right side. The other 2 sides are called the legs, all right? Now, there's a special type of trapezoid called an isosceles trapezoid. And again, isosceles means 2 congruent. So its legs are congruent. So if you look here, the legs A, B, and C, D are congruent. So it looks very symmetrical, right? The left side and right side look very much the same. All right. So not every trapezoid is isosceles. Most of them in the real world are isosceles. Okay, so we have 2 theorems, and these both are about isosceles trapezoids. So again, it's about an isosceles trapezoid. So the first one says, in an isosceles trapezoid, your base angles are congruent. All right, so the base angles. So those are the 2 angles along each base. So along this bottom base, it's angle T and angle P. Along the top base, angle R and angle A. Also, the diagonals are congruent. So in an isosceles trapezoid, because it's nicely symmetrical, AC and BD will be congruent. Okay. All right, the other type of figure they want to introduce us to is a kite. So I'm sure we all have flown a kite. So a kite has 2 pairs of consecutive sides congruent, but it has no opposite sides congruent. Okay. All right. So notice here, right? So it's the 2 next to each other that are congruent, and these 2 that are next to each other. If it had opposite sides congruent, then it would actually be a rhombus, because then all 4 would be congruent. It's not. Okay. The other important thing to recognize is that there are no parallel sides. This is an important discovery with kites. No parallel sides. In a kite, the diagonals will also be perpendicular. If you think of when you fly a kite and the wooden supports behind the kite, they are perpendicular. They form a right angle. Okay. So those are the extra figures. So now we're going to talk about this hierarchy. So this is very important for you, okay? So on Desmos, not Desmos, on Edgelastic, you're going to fill this chart in, okay? You're going to see there's going to be boxes. You're going to type the words in. So just type it in exactly as it says here. So this is a quadrilateral. This is where it all starts, right? Because there's 4 sides. All of these figures have 4 sides. If you have no pairs of parallel sides, you are a kite. If you have 2 consecutive pairs of congruent sides, but if you only have 1 pair of parallel sides, you're a trapezoid, bases. But then you could also be an isosceles trapezoid if your legs are congruent. So be aware of that. And then if you have 2 pairs of parallel sides, our favorite parallelograms, and from parallelograms, you could be a rectangle if you have right angles. You could be a rhombus if you have all 4 sides congruent. And as I said, if you marry these 2 together, if you combine a rhombus and a rectangle, you do get the square, which is the most perfect quadrilateral. It is the regular quadrilateral. So again, you have to fill this chart in on Edgelastic. All right. And that's all for this. Okay. All right. Sounds good. Thanks for watching.